Figures 12.2 and 12.3, community member and shape class hierarchies. In the next two figures, we're just going to take a look at some so-called UML class diagrams that show you the relationships between classes in a couple of different class hierarchies. We'll start here with this community member class hierarchy, and our goal here is to start to introduce the concepts of inheritance and some of the terminology of inheritance that we'll be using in the code examples in this lesson and the next. So here we have again a UML class diagram. Each of these rectangles represents a different class in the hierarchy. At the top of the hierarchy, the class community member is the so-called base class in the hierarchy, and all of the classes that show up below that are known as its either direct or indirect subclasses. So for example, employee, student, and alumnus are all direct subclasses or derived classes of community member. Subclass and derived class mean the same thing. Base class and superclass mean the same thing, and depending on who you're talking to, people will use the base class, derived class terminology or the superclass, subclass terminology. So you should just be familiar with both of those. So again, employee, student, and alumnus are all direct derived classes of community member because they are on the next level down in the hierarchy, whereas all of these other classes are so-called indirect derived classes of community member because we have to go up at least one additional level to get back to the community member class. Now, the key relationship that we define when we implement inheritance in our programs is the so-called is-a relationship. Based on this hierarchy, I can say that an employee is a community member of this university community, a student is a community member, and an alumnus is a community member. And these arrows with the hollow arrowheads are the UML indication of inheritance in a program. So going down the hierarchy, we can also say that a faculty member is an employee and a staff member is an employee. And because an employee is a community member, faculty and staff are also considered to be community members. So the is-a relationship carries all the way up the hierarchy by following the arrows. If you take a look underneath faculty, you'll see that we have administrator and teacher as derived classes of faculty. And so far, all of these different arrows are indicating single inheritance relationships. However, on the very last level, if you will, of this hierarchy, we have a class called administrator teacher with two arrows pointing up, and that indicates multiple inheritance, meaning that in order to create class administrator teacher, we're going to bring in the capabilities from both the class administrator and the class teacher to create this new class, administrator teacher. And an administrator teacher is an administrator and is a teacher at the same time. So some faculty within a university both administer the different departments and also teach within those departments as well. Now, the basic concept of inheritance is software reuse, and the way that we do software reuse in inheritance is by taking existing classes and bringing their data and their capabilities, their behaviors or member functions into these new class definitions to create new, potentially more robust classes with additional data and additional functionality as well. So we've already done some software reuse throughout these live lessons. One form of software reuse is to use, for example, the string class that's built into the C++ standard library rather than creating your own string class. So that's just simply using an existing class. Another form of reuse that we did was the so-called composition relationship, where we build an object of one class into another class definition. So for example, an employee class could have two strings representing the first name and the last name composed within it. So that's another form of software reuse. And then we have inheritance as a third form of software reuse, and that's what we'll be focusing on here in this lesson. Now, let's take a look at another hierarchy just to reinforce what we've just discussed. So here is a shape hierarchy, and you can see here in our shape hierarchy that we have a base class called shape at the top of the hierarchy, and that's going to represent all of the things that are common about shapes. For example, all shapes have color, and so we might define not only the data representing color in the shape class at the top of the hierarchy, but we would also define any member functions that are needed to manipulate the color at that level as well. Then we can inherit all of that into our derived classes, two-dimensional shape and three-dimensional shape, which are two different categories of shapes. Now, by the way, at the top of the hierarchy, you're talking about the more general concept of shape, so that represents a much larger set of objects than just two-dimensional shapes. So by moving to two-dimensional shape in the hierarchy, you've now eliminated a whole category of shapes, the three-dimensional shapes. So two-dimensional shape and three-dimensional shape each represent a much smaller subset of the total set of objects that are known as shapes. Similarly, when you get down to circle, you're becoming even more specific. Circles are a very specific type of two-dimensional shape, and again, a smaller subset of the total number of objects that would qualify as shapes based on this hierarchy. Now, again, within the hierarchy, two-dimensional shape is a derived class of shape, so a two-dimensional shape is a shape. It's a direct derived class of shape because there's just the arrow from two-dimensional shape to shape here. Circle is an indirect derived class of shape, so I can say circle is a two-dimensional shape and is also a shape. Square is a two-dimensional shape and is also a shape, etc., etc. So we'll be using this terminology as we move forward in this lesson, and we'll start to introduce a class hierarchy that we'll use throughout this lesson and the next. The class hierarchy consists of two classes: a commission employee class, which just represents an employee who works based on commissions, and then we're going to create a second class called base plus commission employee, which does all the same things that a commission employee does, but also gets paid a base salary as part of their salary calculation. And we're going to start by creating those two classes independently of one another. Then we're going to introduce the syntax of inheritance and talk about how to implement the relationship between those classes so that we're not repeating code that we could have defined once in our application.